Okay, our next talk is by Konstantin Tennhard, Large-Scale Rails Application.
Hi everyone. Let me start with saying I'm super excited to be here. It's not only my first time at RubyConf Philippines, but also my first time in general in Southeast Asia. And yeah, as Ramon just mentioned, my name is Konstantin Tennhard, and I'm originally from Germany, but I live in Ottawa, Canada these days, and had a 28-hour journey when I first came here. But it has been a couple of amazing days. And as many of the Ruby developers based in Ottawa, I work for Shopify. And you can find me on GitHub or Twitter. My handle is T60. And if you have questions later, you can either ask me at the party or if you prefer, just shoot a tweet in my direction. Before I dive into my actual topic, I just want to quickly mention a couple of open source projects I'm working on, partially because they are actually related to this talk. I recently built a library called Untitled Chapter, which allows you to use Sinatra to intercept HTTP requests in your test suite as an alternative to Webmock or VCR. I'm also maintaining Action Widget, which is the open source implementation of the UI component system we use at Shopify. And relevant to this talk is I maintain Smart Properties, which is a library for defining smarter attribute assessors. So they support conversion, default values, a keyword-based initializer to provide if you flag them as required, and you can provide conversion. And then finally, this is most relevant to this talk, I maintain a library for modeling processing pipelines. The idea for that was actually came initially from my work in natural language processing and machine learning, but processing pipelines are a general purpose tool in computer science, and they can be used to model business processes quite easily. And that's what I want to talk about today, how these processes are being modeled in large-scale Rails applications. Before I start on with the technical aspects of this talk, I want to quickly talk a little about software development itself and what it means to me and potentially what it means to you. For me, software development is all about building sustainable software products. And by that, I really mean products that adapt. There's two major things when you build a product you need to be aware of. The first one is change. If you build a product that is supposed to be around for a long time, then change is potentially one of the hardest things in software development you actually have to deal with. And the thing about change is inevitable because your customer will likely come to you and have new feature requests or wants to have existing feature requests changed. And then there's also internally motivated change, which may just be that you want to upgrade to the latest Rails versions, or that in general new technologies and best practices became available and you just want to update to the latest grades. So since change is inevitable, we really should design our applications to withstand this kind of change. And in a sense, a software product is very much like a living organism. It's constantly evolving and changing. And if evolution taught us one thing, then it is that organisms that are unable to adapt to their current ecosystems die. And that can very much happen to a software product that cannot withstand change. And instead of being afraid of change, you really should embrace change, because again, if you look at evolution, change and evolution, it brought some of the most amazing things to life. The second aspect that is really difficult when we talk about software development is growth. And it is again something that you can't avoid if your product is around for a longer time. And the problem with growth is that it increases complexity. And with an increase in complexity, you usually have a decrease in velocity, simply because it is harder to reason about the entire product. Luckily, the strategies that enable change often also reduce complexity. So they are both sort of intertwined. And now I actually want to look at these two things from a more technical perspective, because I just more or less define these arbitrary concepts, but what does it actually mean for us as software developers? I want to talk about in particular about modular systems and why they are easier to change. And the idea behind modular systems is that they consist of components, and that each component does one thing and only one thing. And if components in a system adhere to this concept, we often speak of highly cohesive systems. The downside of having so many components is that you often have to deal with structural complexity. But that can be easily dealt with by simply organizing your code in a meaningful way. And it's really all about adhering and establishing rules and conventions. And if you as a team or as an entire company can sort of get behind common behavior and common shared beliefs on how to develop software, then dealing with structural complexity is usually not a problem. The other thing about components is that they should know as little as possible about other components. And if components adhere to this principle, we often speak of loosely coupled components. So it's really these two things. We want the system to be highly cohesive and loosely coupled. And now let's talk about Ruby on Rails and what that means in the context of this framework. Ruby on Rails is all about MEC, but nobody ever said that MEC are the only three building blocks you are allowed to use in your Ruby on Rails application. And for an application that has been around for a longer time, you likely will establish patterns, or should establish patterns in your company for solving problems that are specific to your domain and to the type of application you're building. And I want to talk about how you can model complex business processes in a Rails application. And as an example, I just want to use the use case of creating a user. And creating a user is really more than adding just a record to the database, because we might need to fire off emails, we might have to start an onboarding process. So there's usually an entire story behind what it means to create a user, or rather what it means for a user to sign up on your platform. So the first thing we need to do in order to correctly model this process is we need to understand it. And by that we really need to analyze our customer's needs. What does it mean for a customer when they sign up with our product? What do they expect? And once we have a clear understanding of our use case, we should aim at resembling this process as closely in code as possible. And one way to do this is that we organize our code in business transactions, meaning we have one piece of code that models one particular use case. And there's actually a pattern for that called transaction script, and it has been defined by Martin Fowler, the same person who also defined active record. And the reason why transaction scripts can be easily deployed in Ruby on Rails application is first that the web is actually transactional, and the whole idea of a transaction script is that a piece of code is triggered and models an entire use case. And in this case, in the context of a Rails application, this means we receive a request, we then execute a particular transaction, and finally return the result to the user. And as mentioned by Fowler in his book, Enterprise Patterns of Enterprise Application Architecture, transaction scripts play really nice with active background. So in this sense, they are ideal for Ruby on Rails applications. And there's really two ways you can implement them. The simplest version of implementing a transaction script is you use a single function. The function models your entire business process, and your object it depends on or it requires to perform a certain business transaction are simply passed in as method arguments. The other slightly more complex solution is to model them as an entire class. And that is sort of what I want to talk about for those really complex business transactions where you would end up with a method hundreds of lines long. You might want to break it down into a single class or even a pipeline of multiple classes. And in order to implement this in a consistent way, I released an open source project called Composable Operations, which is meant for you to easily implement these transaction scripts. And they are actually a little more than the original definition of a transaction script. As we will see in a moment, they provide some unique features. And these features we best explore through the means of code. So on this slide, I have a CSV export class. It is the class inherits from Composable Operations operation. And we first state that we process a number of records. And we have additionally a property, and I will explain both concepts in a moment, that takes a list of arguments we actually want to, attributes we actually want to export. The algorithmic core of this operation is defined in the execute method. And all we do here is we build a CSV object, we iterate over our records, and we convert each record. And the way we do conversion is simply we iterate over all attributes. We pass in for export to the operation, and then send method calls to our record objects, collect the data, and finally export it as CSV. So there were two important method calls. The method call to the class method processes, which defines the positional arguments your operation takes. And you can take either one argument, or in many cases it might make sense to have multiple positional arguments. If you think, for instance, of defining an operation that adds a user to a group, in this case, it would be logical to take the user and the group as input arguments to your operation. The property method, on the other hand, defines key value arguments your initializer takes, and it allows you to set default values, which can be really useful if we are talking about, for instance, configuration settings for your operation. Let's say one operation performs a database request, and we want by default to limit the number of returned records to 5, but still want to expose this configuration option to the outside world. In this case, we want to make sure that the limit is always specified and it's converted to an integer whenever assigned. And finally, we want to guarantee that this limit is always greater than 0. And this code, as mentioned before, is available separately as the Smart Properties library. As mentioned before, the execute method is used to implement the algorithmic core of the operation. And in this case, I have a very simple operation that doesn't take any arguments. It's sort of used to generate arbitrary parse words. There's two ways of invoking operations. You can either manually instantiate the operation by calling the constructor and then invoking the instance method perform, or more conveniently, you use the class method perform. But there's differences between these two invocations. Before I go into the differences, you might have noticed you implement execute, but you call perform. And the reason for that is that we have that operations provide certain state and control flow mechanisms, which is handled in the perform method, that is sort of wrapped around your definition of your algorithmic or in the execute method. In fact, execute is automatically protected, so you can't even call it on an instance. Operations have 4 different states. When they first are initialized, they are in the state not yet executed, and after you ran them, they can either be succeeded, halted, or failed. And the keyword, the instance methods fail or halt can be used to sort of switch into this state. Operations also support before and after filters that run before and after your execute method. So going back to our CSV export example, we might want to extend it with a before filter that actually ensures that all of our records respond to the attributes we are trying to export, and otherwise fail the operation, explaining that one of the records did not implement the expected interface. So in this case, invoking the operation through the convenience method perform on the class itself will result in an argument error. But if we manually instantiate the operation and call the instance method perform, we will simply get nil as a result, and then have to use the method succeeded, halted, or failed to inspect the state of our operation. And we can also conveniently access the failure that would have been raised by calling exception or message on the operation. And of course, nothing limits you to further extend the CSV operation and to use another pattern in conjunction. And what I'm doing here is I'm using a decorator pattern that allows me to decorate a record before I actually export it, meaning I can call a method that might not exist on the original record. And the way decorate is implemented is pretty straightforward. I check if a decorator has been provided as a configuration option to the operation. If so, I decorate my record. If not, I simply return the record itself. If you have a business process that is more complex than the simple CSV export I just demonstrated you, you might be inclined to split it up into multiple operations, especially if you have shared parts in your operations that could be used in different business processes throughout your application. And so in this case, we speak often of a processing pipeline, which is simply a set of software components connected in series. And the output of one component in such a pipeline is the input of the next component. Meaning, the input of the entire pipeline is what the first operation in the pipeline gets as the input, and the output of the last operation in the pipeline will be the output of the pipeline itself. With composable operations, it's pretty straightforward to define. With these operations, all you need to do is you need to inherit from composable operations composed operation, and then you get the class method use, which you simply call in the order you want to use the individual operations and string them together as a pipeline. One thing to know about composed operations, they are operations themselves, so you could even use an entire pipeline within another pipeline. And in this example, we have an operation A that sort of generates data for the operation B. And some pipeline, when you execute it, will eventually return the result that operation B yields. So let's build an operation for importing a list of users. Let's say we have some CSV that contains the name or the given name, the family name, and the age. And we have a record that simply consists of first name, last name, email, and password. The issue here is that, for instance, our field names in the record object do not align with the field names in the CSV data that we might just have gotten by one of our customers. So when you think about what it means to import data, we really can break it down in like 5 steps. We first need to parse the data, maybe sanitize input depending on where the data comes from, map the columns from the fields in the input data to the fields in our record objects, maybe generate additional data because the initial CSV didn't contain a password, and then finally create the user records in our database. And modeling this in code using composed operations is essentially these 5 steps. The CSV import operation here takes mappings and generators, so you can sort of define external generators, for instance, for creating passwords. And then it uses 5 operations to perform the CSV import. And I won't go into detail about how these individual operations are implemented. Instead, I want to talk about a change in use case. Let's say you have a second customer that provides you with data in JSON, and now you want to import this JSON data. What you could do is you could obviously copy the entire pipeline definition and simply replace the parser. But again, that is still a lot of code duplication. And so what we really want to do is to be able to choose the parser at runtime in our pipeline. So what we need is a placeholder that acts as our parser but can be replaced at runtime. And we often refer to that as a proxy. And a proxy could simply be defined as something, as an operation that takes another operation it will ultimately execute, and a bunch of options it will pass on to this operation. And then we implement our algorithmic core as instantiating the operation, forwarding the input of our proxy and the keyword arguments to our concrete, now at runtime, specified operation. We perform the operation and then we simply copy over the state. The pipeline itself would then look something like that, where we have as a first call our use proxy method. And the proxy is, in this case, the value of the parser property. And by default, this parser is a CSV parser, but we can now instantiate our operation with a different parser. Going one step further to making this code even more clean is we implement 2 convenience methods on our pipeline, simply calling perform and supplying CSV parser and JSON parser respectively as default values. And then we end up with something that reads as simple as import.csv and providing the data you actually want to import. Let's quickly talk about integrating operations into Ruby on Rails. In the project I'm working on, they simply live in the app operations folder. And we usually call them from the controller. We explicitly fetch all the data the operations are working on in the controller, meaning we make all our database requests usually in the controller, then forward them to a particular operation that gets executed and the result finally returned to the user. The nice thing about organizing your code for an entire business process in an operation is that you can easily unit test them and still get great test coverage. And if you use our spec, testing is even easier because composable operations provides you with 2 measures that allow you to either test for success or failure. Let's quickly recap. Operations are a mechanism for grouping code by business process or by use case. Operations have a unified interface that is independent of the underlying business process. They all implement, execute, you always call perform, and you always have this nice definition of positional arguments and configuration options the operation actually takes. Further, they provide flexible composition mechanism, as staff for implementing those more complex business processes, which makes it easy to reuse individual parts or individual operations in multiple pipelines. And ultimately, establishing a pattern throughout your application on how you model business processes aids to the understandability and makes it easier to change and grow over time. The slides themselves are available on this URL. Thanks a lot.
We have time for about just one question. Okay, I guess that means none. But yeah, like he said, thank you. Do you have any questions? Thank you.